Okay, guys, so today we are going to start our next unit, Unit 3. So this unit, we're going to talk all about linear functions. We're going to see a lot of familiar stuff as we work through our problems for today. The difference between last unit and this unit is that the types of questions we ask are going to be very similar, but we're going to focus just exclusively on those linear functions. So on the very first page of your Unit 3 packet, we're going to look at a couple problems that may look sort of kind of familiar. I think on your review for Unit 2, we had a similar problem we're going to look at here for scenario A. So this says a cab charges a $3 boarding fee and then $2 per mile. Let our function calculate the cost of a trip based on the number of miles of the trip, and x would be our number of miles. So over here we have a graph of our function, and then we have our equation. I'm going to go ahead and label our axes. So we know that x would be our number of miles. So I'm going to label that number of miles. And our y-axis, our function, is going to give us the cost of our cab ride here. Okay? So we've got our function here as well. And then our questions are, what do these values in our function represent? So this 2 represents the cost per mile. We don't know how many cost per mile. We don't know how many miles we're driving right off the bat, but however many miles I do drive, we would plug that number in for x, and it would be 2 times that number of miles, since it's $2 per mile. The 3 then would be our sort of standard charge. They called it a boarding fee. Just how much does it cost for me to reserve this cab or to take this cab? As soon as I sit in the seat, I know that it costs me $3 for that boarding fee. So that $3 is the boarding fee. Now, if I think about taking a ride in a cab, it probably doesn't make a ton of sense to sit in the cab and then immediately get back out, right? It would cost me $3 for that boarding fee just to do that, to sit in the cab and then get back out. So when we talk about the domain and range here, I want to keep that in mind. What makes sense for this problem? Remember, the domain would be our x values and the range would be our y values. So for our x values, we're talking about the number of miles that we drive. 0 probably doesn't make a ton of sense. Everybody probably has their own sort of minimum amount of distance they're willing to walk versus when you would decide it's time to drive. And maybe that distance is impacted by if it's raining outside or if it's really cold or if it's really hot. We know that, again, 0 doesn't make a ton of sense, but anything bigger than 0 would be fair game. You've got a lot of really heavy bags, and so you're not willing to walk very far. That's okay. So I'm going to use a parenthesis here to represent that anything bigger than 0 would make sense, but not 0 itself. And then we also, if I'm going to look at taking a cab or an Uber or a ride, getting a ride with somebody, we also have probably a maximum number of miles that they're willing to drive us, right? If I get in a cab and I say, I want you to drive me from Peoria to Michigan, they're going to say no. But there is some sort of reasonable, we'll say reasonable number of miles that would be my upper limit. So maybe they're willing to drive me 20 miles, but not 30 miles. For our range then, we know as soon as we sit in that seat, we owe that $3 boarding fee. So I know it's got to be something more than $3, right? Since we're not going to get in and get back out, it's not going to be exactly 3. It's going to be something more than $3. So that's why I'm going to do 3 with that parenthesis. And then my upper cost, right? Because range is the y, and that's cost here. My upper cost is going to be based on that, whatever that reasonable number of miles is, and that may be different depending on the cab. So we're just going to say it's going to be 2 times our miles plus 3. So whatever this number is, multiply it by 2 and add 3. So we're keeping this one pretty generic, but that's okay. For scenario B, we've got some more kind of concrete information. So scenario B says Sarah was given a $100 Starbucks gift card, and she uses it to buy $5 lattes. Let our function calculate the amount left on her gift card after X lattes. So we know X would be our number of lattes, and Y is going to be the money left on that card. So remember, for a gift card, when I get it, it comes preloaded with a certain dollar amount. And then when I spend money on that card, it subtracts from that total that was on the card to begin with. So if I look at my function here, it says, what does the -5 represent? So remember, $5 was the cost for an individual coffee, a latte, right? We're subtracting it here. It's negative because I'm spending that money. So that means I'm taking it away from the total I had on my gift card to begin with, okay? So what does the -5 represent? The cost of a latte. And then the 100 would be that initial amount on my gift card. So original amount on the gift card. So when we talk about domain and range here, domain, those X values, the number of lattes that we're looking at, the fewest number of lattes I could buy would be 0. And then the most lattes I could buy is going to be limited by that $100. So we can see from our graph here, right at 20 is where I've spent all $100. And that should make sense because 100 divided by 5 would give me 20. Okay? And I'm using brackets here since I could actually purchase no lattes and I could actually purchase 20 lattes. For our range then, our Y values, we're looking at amount on the card. So what's the smallest amount I could have on the card? Well, that would be nothing if I spend all the money. The biggest amount I could have on the card would be what I start with, that $100. And again, brackets because I actually can have those values. We're going to look at a couple more examples that are this sort of similar idea. So if I turn the page and I look at example A on page 86, this time we have the scenario, but we're going to create the equation and the graph. So similar to our gift card problem, which is a bank account starts with $500 and $20 is withdrawn every week for W weeks. So this, again, similar to our gift card. We started with $100 on the gift card and we spent $5 every time we bought a latte. This time we're talking about a bank account. We're starting with $500 and we're taking away 20 every week. So my function is going to look simple. So this says use A of W. So I'm going to use A of W here. And then it says $20 is withdrawn every week. So just like we had that -5 for our latte charge, we're going to do -20 since that's the amount that we're taking out of this account every week. Withdraw means we're taking it out. And it says for W weeks, and then we started with 500. So that's the amount we had originally. Okay, so there's my function. And now if I go to graph this is slope-intercept form, right? Y equals mx plus b. So there's my y-intercept at 500. And then my slope would be -20, or I can think of that as -20 over 1. Okay? So pay attention to your scale on your graph. So here's 0 and here's 5. That means my x scale is going by 1s. Right? That would get me to 5 here. On my y scale, here's 0 and here's 100. So that means my y scale is going by 20s. 60, 80, and then 100. So my y scale is going by 20s. So there's my y-intercept plotted. When I go to do my slope now, I'm going down 20. That's just one sort of notch on my grid, and then over 1. Remember, because the x scale is by 1s. Down 20 over 1, down 20 over 1, down 20 over 1, down 20 over 1. And I could keep doing this for my entire grid. We would get, I'm just going to use my ruler here to create that. I know I'm going to end up at each of these sort of bolded corner intersections. So we would get a graph that looks like this, okay, for our bank account. Now for this second part, we've done problems similar to this, okay? This is our function notation. Remember, this number in parentheses here is our x. This number that we're equal to is our y. So in this case, we know an x value. We're going to use it to find the y. When I have something the opposite, what we're trying to find is the x value based on that given y. So I'm going to use the graph for these. So for this first one, when x is 2, that's right here, follow that up to my graph, and y would be this guy right here. So there's 400, 420, 440, 460, 460. When a is 0, so that's when x is 0, my y value would be 500. And I'll do the other one that's like this. So when a is 10, my y would be 300. And then for that reverse process, this means that my y is 140. So 100, 120, 140. Follow that to my graph and then give the associated x. So there's 15, 16, 17. This would be 18. 18 is my x value there that matches that y. When y is 400, that's right here, our x would be 5. And then when y is 0, that would be right here, our x on our graph would be 25. Domain and range for our next question. Remember, domain is the x and range is the y. So our domain for this function, what kind of x values can we have? Remember, our x, in this case w, represents the weeks that we are withdrawing money from our bank account, and our y represents the balance for that bank account. How much money do I have in the account? Okay. So if I look at my domain, what's the smallest or the lowest number of weeks that we considered? Well, that would be 0. And the greatest number of weeks that we would consider? That would be here, 25. Our range then would be those y values. What's the smallest y value that it makes sense to consider? Well, that would be when y is 0. And our greatest y value we want to consider would be 500. And then the last couple questions are about x and y intercepts. So our y-intercept for this graph, we can see on the graph itself, right, when we cross the y-axis, that happens when x is, or when y, I should say, is 500. So 500. We can also see that here in our function notation. The y-intercept happens when x is 0. When x is 0, y is 500. Okay? And then what does this represent in terms of the problem, in the context of the problem? So week 0, right, we have $500. That would be one way that you could describe what's happening here. The other way that we could think about this would be to say week 0 is before we've started taking out money. So we start with $500, or our account initially has $500. So I'm going to say we start with $500 in the account. Or again, if you would rather, at week 0, there is $500 in the account, or the balance on the account is $500. Our x-intercept will be when the graph crosses the x-axis. So that would be here where we touch the x-axis. So that's 25. Again, we also saw that in our function notation here. The x-intercept happens when y is 0. So y is 0 when x is 25. For the context of this problem, that 25 would be the number of weeks that it takes to reduce our balance to 0. We have $0 after 25 weeks. Again, there are several ways to phrase that. We have $0 after 25 weeks. After 25 weeks, we have withdrawn all the money from the account. Any of those options is fine. We have one more problem we're going to look at today. We're looking at another bank account problem, but this time instead of taking money out of the account, we're going to put money into the account. So our savings account starts with $475, and then each week we're going to deposit $125 from our paycheck. So we're adding to this total every week. Our goal is to save $7,000 for college. Write a linear function that represents our bank balance. So our function this time, we're going to use b of w. And this time, since we're not taking money away, we don't want this weekly change to be negative. We want it to be positive since we're adding. So this would be 125W plus 475, that original amount. The next thing we have are some of those function notation evaluating practice problems. We're going to use our function this time. So remember, this is telling me that I'm plugging in x equals 10 to my function. So 125 times 10 plus 475. Please, at the very least, show me your setup for these problems. If you show me every step of work, that's excellent, but at least show me your setup. That way, on a quiz or a test, if you have a wrong answer, I can look back at your work and see if that answer is wrong because your setup was wrong or because you made an algebra error somewhere down the line. Okay, so show me your work, show me your setups. So once you have your setup, you can type that in your calculator, that's fine. This would come out to be 1,725. Here we're plugging in x equals 0, so that would be 125 times 0 plus 475. Maybe a little easier to evaluate this one. Anything times 0 is 0, so we would get 475 there. And then when we plug in 16, 125 times 16 plus 475. Again, if you want to use your calculator to simplify this, that's fine. We would get $2,475 there. For the last three problems, remember this time we know what the y is. So we're putting that in where we see b of w. So we would have 3225 equals 125w plus 475. And then what we're going to do is sort of unravel this to get w by itself. So in each of these problems, my number on the left is going to be different, but our steps are going to be the same. So I'm going to start by subtracting 475 from both sides. So that would give me 2,750 equals 125W. And then divide both sides by 125 to get W by itself. And we would get 22 for W. Same idea here. Plug in our Y value this time. And then I'm going to see the same steps to solve for W. So subtract 475 from both sides. So we get 4625 over here equals 125W. Divide both sides by 125. I'm running out of room here. And we would get W to be 37 in this case. And then here, 7,000 equals 125W plus 475. Subtract that 475 from both sides. We want to get W by itself, so that's the first thing to go. So this would give us 6525 equals 125W. Divide both sides by 125 to get W by itself, and we get 52.2. Now, remember, 7,000 was the goal, right? The goal was to save $7,000 for college. So what this is telling me is that if I saved for 52 weeks, I wouldn't be quite there. I need a little bit more than that amount I save in 52 weeks. So I actually need 53 weeks, right? Because we're making one deposit a week. So I need that 53rd week deposit in order to meet my goal. 53 weeks to meet my goal. And that's important when we talk about domain and range. So domain here would be, again, our X, our number of weeks. So we're starting at 0, and we have to go to 53 weeks to meet that goal. Oops. And then for our range, we know we start with 475 in our account, and that amount increases until we get to our goal is to get to 7,000. So in 53 weeks, we'd actually make a little more than 7,000, but I'm just going to leave that as 7,000 since that's our goal amount. Our y-intercept here, which we can see since, again, this is slope-intercept form, there's our y-intercept, or the y-intercept happens when x is 0, so that would be 475, however you choose to look at that. Our y-intercept is 475. So remember, you could think of that as this is the amount in our account at 0 weeks, or this is the amount, amount in the account when she starts saving. For college. A lot of different correct ways to phrase that, but that's what we're looking at there. How much money do I start with? And then we don't have an x-intercept that we found in here. I just want to talk for a second about what an x-intercept is. So we know our y-intercept is up here at 475, and then we are increasing from there. So for the context of our problem, we're only looking at this first quadrant. But if I were to think about an x-intercept here, if I were to sort of trace this back, that x-intercept would represent an x value when y was 0. Our x value would be, since we're negative here, some negative number means time in the past when the amount in our account was 0. And x-intercept would be the number of weeks in the past when the account balance was $0. So when did we have no money in that account? Okay, that is it for today's lesson. Make sure that you completed your 2 Khan Academy assignments and email me with any questions. Have a great day, you guys.